In the diagram below, O, 0, 0, A, 6 minus 3, and B, 4, 0, are the vertices of triangle OAB. P is a point on OA, such that BP is perpendicular to OA. Determine the angle of inclination of OA, the equation of BP, and the coordinates of P. The angle of inclination of a straight line is measured in an anticlockwise direction, from the positive x-axis. So, to find the angle of inclination of OA, we will need to first extend the line, and indicate this angle of inclination, which we will call theta. Now, the angle of inclination of a straight line is directly related to the gradient of the line. We therefore need to determine the gradient of line OA, which is minus a half. The gradient of OA, which is minus a half, equals tan theta. The fact that this is a negative ratio, means that the angle theta lies in a quadrant where tan is negative. Theta is clearly an obtuse angle, so we establish a reference angle and subtract it from 180 degrees. Theta therefore equals 153.4 degrees. To determine the equation of a straight line, we need to know the gradient of the line, and the coordinates of a point that lies on the line. For line BP, we know the coordinates of point B, which are 4, 0. To find the gradient of BP, we will use the fact that BP is perpendicular to OA. The gradient of BP is therefore 2, since the product of the gradients of perpendicular lines is minus 1. And now that we know both the gradient of BP, and we have a point that lies on it, we can determine the equation of BP, which is given by y equals 2x minus 8. To determine the coordinates of P, which is the point of intersection of line segments BP and OA, we will equate the equations of these lines. We have just determined the equation of BP, so we proceed likewise to determine the equation of OA, which is given by y equals minus a half x. Finally, to determine the coordinates of P, we equate the equation of these line segments. P is therefore the point, 16 over 5, minus 8 over 5. If you are unsure about anything we have just done, or just want to refresh your memory, these concepts are covered in detail in the workbook, and in the online courses, the links of which have been provided in the description box below. In the diagram below, 6 equal circles are placed in a rectangle OPQR, such that adjacent circles touch externally. A, 1, 1, is the center of the bottom left circle, which touches both the x and y axis. We are required to determine the equation of circle center F, the area of the rectangle, and the equation of the circle with center A, that passes through point E. To determine the equation of circle center F, we need to know both the coordinates of F, and the radius of the circle. Since A is the point, 1, 1, we can deduce that A lies 1 unit away from the y-axis, and 1 unit away from the x-axis. The radius of the circle is therefore 1, and this is true for each circle, since we are told that the circles are equal. The coordinates of center F are therefore 5, 3. And now that we know the coordinates of F, and the radius of the circle, we can determine the equation of circle center F, which is given by x squared minus 10x, plus y squared minus 6y, plus 33 equals 0. The length of the rectangle is 6 units, since it is comprised of 3 diameters, each of which is 2 units in length. Likewise, the width of the rectangle equals 4 units. The area of the rectangle is therefore 24 square units. Finally, we are required to determine the equation of the circle center A, that passes through point E. In other words, the radius of the required circle is AE. We use the distance formula to determine the radius of this circle, which is 2 root 2 units. And now that we know the radius of the required circle, we can determine the equation of the circle, which is given by x squared minus 2x, plus y squared minus 2y, equals 6. If you like this video, subscribe below, hit the like button, and leave a comment to let us know what else you'd like to see. Thanks for watching.